All right, we're starting off this cycle 4 assessment number 3 with problems 1 through 3. The first is a one-step problem. All we're simply doing is subtracting 6 from the variable. Our minus 6 equals negative 13. How do we undo minus 6 with a plus 6? What we need to do is rewrite what's there first, because if we're going to undo this with a plus 6, what are we adding 6 to? We're adding 6 to what's already there. So we've got to make sure it's written there. That's what we're writing. That's what we're adding 6 to. So we take that, add 6 to it. We take what's on the right-hand side and add 6 to it. Okay, if you do it to one side, you do it to the other. These two undo each other. It's the reason we chose plus 6, because it undoes that minus 6. Are equals. And now negative 13 plus 6. These are negatives, these are positives. These 6 positives will cancel out 6 of these negatives, but there's negatives remaining. How many remaining? 7. R equals negative 7. Put a box around it, write the word proof, and then write the original equation unchanged at the start. This is to ensure that we didn't miscopy it. And when we can look down and we can say, okay, the next line is definitely exactly the same, except where there was a variable, we put parentheses and the value inside it. Okay, and it's just easy to compare that. Yes, we started with the original equation, and yes, when we substituted it in, we got it right. We can see what we're substituting into. Okay, negative 7 minus 6 equals negative 13. Well, these are negatives. We're down 7, and we're taking away another 6. So we're down 7. Keep going down another 6, we're down 13, or negative 13. Negative 13 equals negative 13. Check. Great. Okay. Problem 2. By the way, I'm just covering this up to make sure that we're not distracted by a different problem. Okay. T divided by negative 4 equals 7. This is not subtracting 4. Just to be clear, it's dividing by a negative 4. Okay. This is, you can see this as subtraction in some situations, but it's not always subtraction. And in this case, it's just the sign of this number. It's a negative. Okay, so how do we undo that divided by negative 4 with a times negative 4? This is an example of why we're writing the number we're multiplying by to the left-hand side. Because if we wrote on the right-hand side, if we, instead of writing it there, we wrote it here, to multiply by negative 4, then what you're really doing here is just taking this and subtracting 4 from it. This is not multiplying by negative 4. Now you could write that and still actually do the multiplication. You could treat it like it was multiply and multiply, but what it says is something different. And if someone jumped into this problem trying to finish it for you, and they had started with this line and that's what it said, it would appear that this says minus 4, not times the negative 4. And we always want to be writing what we mean and not just assume someone knows that we've done what we mean to do. So we actually multiply by negative 4 to undo divided by negative 4, and we write it first. Negative 4 times everything that's there equals negative 4 times everything that's there. By the way, that explanation about why it's got to go on the left-hand side, watch it again if you didn't get clarity on it, because it will make sense to you eventually if you watch it. Okay, this undoes this, leaving you just with t, and negative 4 times 7, negative times positive is negative, and 4 times 7 is 28, so t equals negative 28. So for the proof, we rewrite the original equation unchanged. On the top only, because that's where t is, that's where we put parentheses and where we write negative 28. Don't bring the parentheses all the way down, because that's not where t is. T is just in the numerator, so we write the parentheses in the numerator and substitute it in there. Write everything else the same. Divided by negative 4 equals 7. And now, negative divided by negative is positive. 28 divided by 4 is 7. So positive 7 equals positive 7. Check. Okay. One more, number 3. Okay. This one is one of these types of problems that you can do it as a one-step problem. Okay. Some of you may know how to do this as a two-step problem, and you could first undo divided by 7 with a times 7, and then undo times 2 with a divided by 2. You could do it in 2 steps. It works. And if that's how you're doing it, I won't consider it wrong or mark it wrong. But you don't need to do it as a two-step problem. You can do it as a one-step problem. How do we do it as a one-step problem? We undo this 2/7 multiplying p, 2/7 p equals 12. We undo this times 2/7 by multiplying by its reciprocal, 7/2. So we write 7/2, parentheses, everything that's there, equals 7/2, parentheses, everything that's there. Why does multiplying by the reciprocal work for what we're trying to do? Because what we're trying to do is get us to a single p value, okay? And I will write this here for the moment. If you do 7 times 2 on the top and get 14, and you do 2 times 7 on the bottom and get 14, then what you've got is 14/14, or 1p. But we don't write 1p, we just write p, okay? But that gets us where we want, which is just a single p. So by multiplying by the reciprocal, you ensure that if there's a 7 on top, it gets multiplied by the 2 that was on the bottom, and the 2 that already is on the bottom gets multiplied by the 7 on top. If you multiply a fraction by its reciprocal, you will always get the same number top and bottom as a result, which means you are getting 1. Okay, so 1p, or just p. And then how do we deal with it over here on the right-hand side? Well, two things are happening here. You are taking 12 and you are multiplying by 7 and dividing by 2. Okay, you could do it first. You could do the multiplication first, okay? And you could say 7 times 12 is 84, and then divide 84 by 2, but you could also divide first. You can do them in either order, and so we are going to divide first. I'm going to just show you what it looks like when you divide first. When you divide first, you get 12 divided by 2 is 6. Now we've got a small number. 6 times 7 is 42, okay? Multiplying this gives you 84, and 84 divided by 2 is still 42. So it works either way, whether you did the multiplication first or whether you do the division first. But by doing the division first, if it divides nice and neatly, it does, results in a whole number. 12 divided by 2 is 6. That makes it really easy because now you've got a small single-digit number, 6 times 7, to get this, versus going big to 84, which maybe there's more room for error and actually getting the wrong number before you divide by 2. So I suggest you do the division first, as long as it results in a nice even integer number, whole number. So 12 divided by 2 is 6, 6 times 7 is 42, and here these undo each other to be 1, p, or just p. P equals 42. Box it. Now, for your proof, write the word proof, then write 2/7 p equals 12, the original equation unchanged. By the way, this is a fraction problem. I want you, if you are not able to write the entire fraction 2/7 on one line, and you can see when I do it, look at how small and sloppy and impossible to read. Okay, if you can't clearly read it by writing it on one line, or you can't stay within the blue lines when you do it, then you should be using 2 lines for your fraction like I am. Put an entire digit, the numerator on top, and then the entire denominator on the bottom, and use 2 lines. So that's what I'm doing here. That's what I expect you to do. And then, of course, also, you should be skipping a line. Okay, so use 2 lines for the fraction, skip a line, use 2 lines, skip a line, etc. Okay, so here we're using 2 lines. 2/7 p equals 12. When we substitute in for p what is equal to 42, that 42 is a single number. Your numbers either go on this line or this line. This number goes on the top line, this guy goes on the bottom line, but you're not writing the 42 like this across the lines, okay? We're trying to organize our work very neatly, okay? We're working deliberately to be neat. So how do we do it? Well, if it's a single digit, it's really, you can imagine, over 1. You should know any whole number is over 1, which makes the numerator the obvious correct location for this whole number is in the numerator or on the top line, okay? So all of that to say that fractions should take 2 lines and whole numbers should take one line and be on the top, the first line. So again, let's do the trick where we do division first, because otherwise you're doing 2 times 42 is 84. And what's 84 divided by 7? You can do it. It's still equal to 12. But it's much easier to say 42 divided by 7 is 6. And now 6 times 2 is 12. I'm trying to teach you how to work competently with fractions. Okay, so 42 divided by 7, 6. 6 times 2, 12. 12 equals 12. Check. Good.